Finding new discoveries outside of Earth isn't an easy job, but scientists are doing their best to succeed. It wasn't until recently that a group of astronomers decided to explore the Jovian system, which includes Jupiter and its moons. What they discovered next will leave us all stunned. Hello and welcome back to our YouTube channel. Today we will reveal the most recent discovery on Jupiter's moon, which has astounded not only ordinary people but also scientists. So without further ado, let's begin. Jupiter almost qualifies as a solar system unto itself, with 79 known moons, including 4 large moons known as the Galilean Satellites. The majority of Jupiter's moons are small, with approximately 60 of them measuring less than 6.2 miles in diameter. The number of moons can change on a regular basis, with the 79th moon reported in July 2018. The majority of the moons were discovered in the late 1970s and early 1980s. It was a result of automated spacecraft explorations such as NASA's Voyager in 1979 and Galileo in 1995. Galileo Galilei discovered 4 of Jupiter's moons in January 1610, which are now known as Io, Europa, Ganymede, and Callisto. Io, the first moon discovered, is the closest of the Galilean moons to Jupiter. This satellite's distinguishing feature is its volcanoes, which make it the only celestial body in the solar system with volcanic activity other than the Earth. Moving outward from Jupiter is Europa. It is one of the largest bodies in the solar system. Despite being slightly smaller than Earth's moon, Ganymede is Jupiter's 3rd Galilean moon and the largest of the 4. Its distinguishing feature is that it is the only moon with its own magnetic field. Callisto is Jupiter's 4th and farthest Galilean moon. It is the solar system's most cratered object. Published in Nature Astronomy, a group of scientists led by Dr. Xiangjia Jia found compelling evidence that one of Jupiter's moons, Europa, has been releasing water into space in the form of plumes. This unexpected finding was made possible by anomalies discovered in decades-old data from NASA's Galileo mission. This discovery not only demonstrated the importance of archival data, but also had critical implications for the search for extraterrestrial life. Scientists had previously detected giant geysers erupting into space, but they couldn't prove they contained water until now. Europa has long been regarded as a promising candidate for alien life due to its potential habitability. It is the 6th largest moon in the solar system, with a thin, tenuous oxygen atmosphere and a magnetic field, both of which are necessary components of a habitable environment. Europa's most intriguing feature, however, lies beneath the miles of ice that make up its surface, a vast saltwater ocean. Europa, in addition to having liquid water, has a few other unusual characteristics that make it an important location for the search for alien life. According to research published in the late 2017, Europa may be the only non-Earth object in our solar system with plate tectonics. Due to this new enticing hint of habitability, the discovery of strong evidence for Europa's plumes represents a once-in-a-lifetime opportunity to potentially detect the first signs of alien life. It would be prohibitively difficult to sample and observe Europa's ocean without the plumes, but their presence allows scientists to conduct these experiments. An ocean material that is being ejected into space. Due to Hubble Space Telescope imaging, the possibility of plumes on Europa has been discussed in previous years, but the data were at the observatory's sensitivity limit. Scientists were able to measure the moon's water vapor using one of the world's largest telescopes, the W.M. Keck Observatory in Hawaii. From February 2016 to May 2017, they studied the moon for 17 nights, finally detecting a specific infrared signal that could only be caused by vapor erupting into space in mid-April 2016. Researchers discovered 5,202 pounds of water vapor, enough to replenish an Olympic-sized swimming pool. It may be difficult to imagine life flourishing on a seemingly inhospitable moon. Europa does not appear to be the lush, inviting world envisioned by science fiction. With its potentially high radiation, lack of nutrients, frigid temperatures, and distance from the sun, despite how unlikely it may appear, similar environments are potentially habitable on Earth, and organisms that can thrive in even harsher conditions have been discovered. A few months ago, astronomers discovered traces of water vapor in none other than Jupiter's largest moon, Ganymede. The discovery could shed light on similar liquid atmospheres that may shroud other frozen worlds in the solar system and beyond, according to the researchers. According to a previous study, Ganymede, which is larger than Mercury and Pluto and only slightly smaller than Mars, it could carry more water than all of Earth's oceans put together. The Jovian moon, on the other hand, is so cold that the water on its surface has frozen solid. Ganymede's liquid water would be about 100 miles, 160 kilometers, below its crust. The Hubble Space Telescope's new and archival datasets were used to make the discovery, which was reported in the journal Nature Astronomy. Astronomers re-examined Hubble's observations from the last 2 decades to find this evidence of water vapor. Hubble's Space Telescope imaging spectrograph captured the first ultraviolet (UV) images of Ganymede in 1998, revealing colorful ribbons of electrified gas recognized as auroral bands and providing further substantiation that Ganymede has a weak magnetic field. The presence of molecular oxygen explained the similarities in these UV observations. However, some of the observed features did not correspond to the expected emissions from a pure O2 atmosphere. At the same time, the scientists concluded that the disparity was most likely due to higher atomic oxygen concentrations. The team was led by Lorenz Roth. He was an alumnus of the KTH Royal Institute of Technology in Stockholm, Sweden. They planned to use Hubble to measure the amount of atomic oxygen as part of a large observing program to support NASA's Juno mission in 2018. The analysis used data from 2 instruments, Hubble's Cosmic Origins spectrograph in 2018 and archival images from the Space Telescope Imaging Spectrograph (STIS) from 1998 to 2010. They were shocked to discover that, contrary to previous interpretations of the data from 1998, Ganymede's atmosphere had essentially little atomic oxygen. This implies that the apparent differences in these UV aurora images must have another explanation. Roth and his colleagues then examined the relative distribution of the aurora in the UV images. The surface temperature of Ganymede varies dramatically throughout the day, and around noon near the equator it may become sufficiently warm that the ice surface releases, or sublimates, some water molecules. Indeed, the perceived differences in the UV images are directly related to where water is expected to be found in the moon's surface. Roth explained that so far, only molecular oxygen had been detected and that this was due to charged particles eroding the ice's surface. The water vapor being measured is the result of ice sublimation, which occurs as a result of the thermal escape of water vapor from warm, icy regions. With the European Space Agency's JUICE mission, Jupiter Icy Moons Explorer, set to launch in 2022 and arrive at Jupiter in 2029, this new data will allow the ESA to fine-tune their observation plans. The JUICE mission will supposedly spend 3 years studying Jupiter and its 3 largest moons, that is, Ganymede, Europa, and Callisto. While Ganymede is subject to 700 times more natural radiation than Earth and 100 times that of Mars, far too much for humans to live on the moon, astronauts may be able to explore the surface for short periods of time if adequate protection is provided. It might actually have the potential to be a habitat for future human exploration. Astronomers will be able to better understand how gas giants form and evolve as they gain a better understanding of Jupiter and its history, shedding more light on the mysteries of our place in the universe. With this, we have reached the end of the video. Make sure to subscribe, like, and share our channel. Don't forget to hit the bell button for early updates. We'll see you in the next one. Until then, peace.